6th grade, Module 5, Lesson 17, Classwork. Opening exercise. Write a numerical equation for the area of the figure below. Identify and explain different parts of the figure. Okay, so we just need to find the area of this triangle. So remember, area of a triangle is equal to 1/2 base times height. So we can find the area by doing 1/2. So the base is 5 there and 9 there. So together, it's 14 centimeters. Times the height is right here, 12 centimeters. So let's solve 14 times 12 and then find half of that. $168, and then half of 168. 2 goes into 16 8 times. Bring down the 8. 2 goes into 8 4 times. So we get 84. So the area is equal to 84 centimeters squared. So it wants us to identify the different parts of the figure. So we can go through and say, let's see, so we identified the base. So let's say the base is equal to 14 centimeters because 5 centimeters plus 9 centimeters equals 14 centimeters. And the height is equal to 12 centimeters, mainly because it's labeled. And yeah, so let's move on to the second part. How would you write an equation that shows the area of a triangle with base B and height H? Well, we already wrote that. Area is equal to 1/2 base times height of a triangle. Part B, write a numerical equation for the area of the figure below. Identify and explain different parts of the figure. So for the area of a rectangle, we just do base times height. Area is equal to base times height. So we have base is 28 feet times the height is 18 feet. So let's do 28 times 18. 8 times 8 is 64. 8 times 2 is 16 plus 6 would be 22. 1 times 8 is 8. 1 times 2 is 2. We get 504. And it's not a triangle, so we're not taking half of it. So the area is just 504 feet squared. Then we need to label, identify, and explain different parts of the figure. So 28 feet represents the base, and 18 feet represents the height. And then again, part 2 says, how would you write an equation that shows the area of a rectangle with base B and height H? Well, area is equal to base times height for a rectangle. Example 1. Use the net to calculate the surface area of the figure. Note all measurements are in centimeters. All right, so I'm going to go through and label all the measurements. So that would be 2 centimeters. Here's just 1 centimeter, 2 centimeters. These are both 1 centimeter, 2 centimeters, 2 centimeters, 2 centimeters. Here's 1 centimeter. 2 centimeters, and then both of these are 1 centimeter. So now we can find the area of all of these pieces of the net and use them to find the surface area. So if we were to, I'm going to start at the top here. So if we have this one, 1 centimeter by 2 centimeters, 1 by 2 would be equal to 2 centimeters squared. So then this one is also a 1 by 2. 1 by 2. And here we have another 1 by 2. This one is also 1 by 2. This one is 2 by 2. And then another 2 by 2. So I'm going to solve over here because there wasn't enough space. So what we're going to add together is we're going to have 1 times 2 plus another 1 times 2. Actually, you know what I'm going to do? I'm going to count how many 1 by 2s I have. I have 1, 2, 3, 4. So 4 groups of 1 times 2 plus, then I have, let's see, 2 groups of 2 by 2. So that's just going to save me from writing out all of these numbers a bunch of times. So 4 times 1 times 2 is, that would be 8, plus 2 times 2 is 4, so plus another 8 will be equal to 16 centimeters squared. So all of those add up to 16 centimeters squared. And so that's the surface area. So example 2, use the net to write an expression for surface area. Note all measurements are in square feet. So here we just have to write an expression. So it looks like we have, these are 3 centimeters on all sides. So all 3 centimeters. And then the height, we don't know the length of this, but that's okay. We don't need to, because to find the area of a triangle, we do height. So the height is 2 centimeters on all of them, because you can see it stretches from here to here, so that's 2 centimeters. And over here, it measures from across this one and this one, so it's also 2 centimeters. And the height here is 2 centimeters. So what we would have is let's start with the square in the middle. So we have 3 by 3 plus 4 groups of, because we have 4 of the triangles, and then to find the area of a triangle, we do 1/2 base times height. So 1/2, 4 times 1/2 times the base is 3 and the height is 2. So you could write it something like that, or we could do 3 times 3 plus 4 times 1/2 times 3 times 2. We can do that. There's different ways you can group it as long as we do it all together. So then it says write an expression, so we don't necessarily need to solve it, but I'm going to go ahead and solve it. So we have 9 plus, let's solve these in the parentheses. So we have 3 times 2 is 6. So we need to find half of 6. So 9 plus 4 times half of 6 is 3. So 9 plus 12 would be equal to 21. So the surface area is 21 square feet. Exercises. Name the solid the net would create, and then write an expression for the surface area. Use the expression to determine the surface area. Assume that each box on the grid paper represents 1 centimeter by 1 centimeter squared. Explain how the expression represents the figure. Okay, so let's start by naming it. So the base is let's see, it's 4 centimeters by 4 centimeters. So it's a square because it's all 4 centimeters. So we have a square, and then it only has one base, so it's going to fold up into a pyramid. So this is called a square pyramid. So now let's create an expression for the surface area. So the base of this triangle is 4 centimeters. The height is 3 centimeters. And we have 4 groups of that. So to find the surface area, we would do, let's start with the square in the middle, 4 centimeters times 4 centimeters plus, then we have 4 groups of 4 triangles of 4 times 1/2 times the base is 4 centimeters. Here, 4 centimeters, and the height is 3 centimeters. So then we can go ahead and solve that. So 4 centimeters times 4 centimeters would be 16 centimeters squared, plus, let's do 4 times 3 is 12, and then half of that would be 6, so 4 times 6 centimeters squared. 16 centimeters squared plus 24 centimeters squared would give us 40 centimeters squared. So the surface area is equal to 40 centimeters squared. And the last step says explain how the expression represents the figure. Let's see. Let's say, so the figure has a square base that is 4 centimeters by 4 centimeters and 4 triangles that measure 4 centimeters by 3 centimeters. All right, number 2. So let's figure out first what this would be. So we can call these the bases. So the bases are rectangles, and there's 2 of them. Even if you were looking at, say, these 2, you could call these 2 the bases, or we could call these 2 the bases. Either way, depends how you want to sit this prism up, because there are 2 bases, 2 matching ones. It's going to be a prism. So this is a rectangular prism. So let's find the surface area. So this is 2 centimeters. This is 5 centimeters. Let's see, 1, 2, 3, 4, 5 centimeters here. 5 centimeters, 2 centimeters. So I'm just going around and counting, basically, so that I can label all of the sides, which will then help me to figure it out what they should be. So now I'm going to write in each one what it is. So this is 5 by 2. Here we have a 5 by 5. There's another 5 by 2. 5 by 2, 5 by 5, and 5 by 2. So now I can write my expression. So I have 2 groups of 5 by 5. So I'm going to say 2 times 5 centimeters by 5 centimeters. Plus I have 4, 1, 2, 3, 4 groups of 5 centimeters by 2 centimeters. So that's where that expression comes from. So now we can solve. So 2 times 25 centimeters squared plus 4 times 10 centimeters squared would be equal to 50 centimeters squared plus 40 centimeters squared, which is equal to 90 centimeters squared as the total surface area. So where did we find everything? We can say the figure has 2 square faces. That measure 5 centimeters by 5 centimeters, and 4 rectangular faces. That measure 5 centimeters by 2 centimeters each. All All right, number 3. So I see that the base here is 3 centimeters by 4 centimeters. So it's a rectangle, and there's only one. So this is going to be a rectangular pyramid. So let's go through and label all the sides. So that's 3 centimeters. The height of this triangle is 1, 2, 3, 4 centimeters. So is this one 4 centimeters, 4 centimeters, and then this is 4 centimeters, and this is 3 centimeters. So now I'm going to go in and write how I would find the area of each one. So let's start in the middle. So this is a 3 by 4. So I'm going to do 4 times 3 to find the area of that rectangle. Now I have triangles. So here I'm going to do 1/2. The base here is 3 times the height is 4. 1/2, 3 times 4. This one would be 1/2. This time the base is 4 and the height is 4. This will be 1/2. The base is 3 times the height is 4, and this is 1/2, the base is 4, and the height is 4. So let's write that as an expression. So I'm going to start with the rectangle because there's only one. So we have 4 times 3 plus, sorry, this got a little messy. These two are the same, 1/2, 4 times 4. So I'm going to do plus 1/2. Actually, there's 2 groups of them. So I'm going to write it 2 times 1/2 times 4 times 4. Plus, then I also have these two that are 1/2 times 3 times 4. So 2 groups of 1/2 times 3 times 4. So now we can solve. So 4 times 3 is 12. I should have written the centimeters on there, but I'm going to write centimeters squared plus 4 times 4 is 16. Let's do 2 times 16, and half of 16 times 8 centimeters squared plus 2 times 3 times 4 is 12. Half of that is 6. So we would have 12 centimeters squared plus 2 times 8 is 16 centimeters squared plus 2 times 6 is 12 centimeters squared. So I can do 12 and 12 is 24. 24 plus 16 would be 40. So we get 40 centimeters squared as the surface area. So let's explain how we got that. So the figure has one rectangular base that is 4 centimeters by 3 centimeters, 2 triangular faces that each measure, actually let's say each with a base of 4 centimeters and height of 4 centimeters. It also has 2 more triangular faces with a base of 3 centimeters and height of 4 centimeters. Okay, and the last one, number 4. Let's figure out the shape first. So I see a bunch of rectangles, so I know it's going to be a rectangular something. I'll use a different color so we don't get confused with the last one. So it's going to be rectangular, and this is going to fold up into a prism because it has 6 sides, which means it's going to have 2 faces or 2 bases. So let's go through and label the measurements. So that's 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5. Okay, so I'm going to go through and put down how I would find the area of each one. So this top one would be 1 by 6. This would also be 1 by 6. This would be 6 by 5 and another 6 by 5. And then these 2 sides are 1 by 5. So now I'm just going to make an expression of those. So I have 2 groups of 6 by 5, so 2 times 6 centimeters by 5 centimeters, plus I have 2 1 by 5s, 2 times 1 centimeter times 5 centimeters, plus then I have 2 1 by 6s. So if I solve that out, 6 times 5 is 30 centimeters squared, plus 2 times 5 centimeters squared, plus 2 times 6 centimeters squared would be 60 centimeters squared, plus 10 centimeters squared, plus 12 centimeters squared. So 60 plus 10 is 70, plus 12 would be 82 centimeters squared for the surface area. So let's say the figure or the prism has 2 6 centimeter by 5 centimeter rectangles, rectangular faces, 2 1 centimeter by 5 centimeter rectangular faces, and 2 1 centimeter by 6 centimeter rectangular faces.